All right, new day, new laptop to repair, and this time we have an XPS 15. So this is the 9530. This is a 2023 version of this laptop. The customer said that they had a blue screen come up that said something about a power state failure, and then the laptop shut off and wouldn't come back on. So I haven't looked at this yet. Let's look at it together and see if we can get this laptop figured out. All right, hitting the power button, we got nothing, no power. Let's plug in a charger into it and see what comes up. Okay, I can see that it's negotiating the 20 volts. So on a USB-C charger, it puts in 5 volts, and then the laptop communicates with the charger and pushes up to 20 volts. So we got the 20 volts negotiated here, but as you see, it's not pulling any current at all. Zero current, and it should be at least pulling current to charge the battery or even turn on the EC chip. So I'm gonna hit the power button and see if that changes at all. All right, and we see that nothing's happening here. So this means we're gonna have to open up the laptop and take a look inside. So let me do that real quick. Okay, the bottoms on these are very hard to get open, and I'm gonna look and see if someone has opened this in the past. And I do see a little bit of, you can see frayed metal here. So it looks like somebody probably has opened this in the past. Oh, yep, and the bottom's coming off pretty easy. I should not be able to pull the bottom off with my fingers like this, so that means that somebody has been in here. But let's take a look inside. Okay, so taking a look around, we have the main battery here. This is a Dell genuine battery, has a serial number here. Here's the hard drive, it's a 2280. We got a couple memory sticks here. I can see some heatsink compound right on top here, which is kind of interesting. There's a little bit more right there. So somebody has probably pulled this heatsink off at some point. The fans are pretty clean. I don't see any debris in there. So this circuitry right here is going to be where it produces the main power rail. It's going to take the 20 volts from the USB-C charger and come here, and it's going to produce a 12.6 volt main power rail. That's the same voltage of the battery whenever it's fully charged. Over here is going to be the 3 and 5 volt power rails, these big coils here. There's a Wi-Fi card. All right, let's plug in the charger and let's get under the microscope. All right, so here's where the USB-C charger comes in through the USB-C port, and that's going to come over here. Here's the PD controller, so this is what communicates with the charger. And then this produces the 20 volts. So the 20 volts should be on one side here, and then these should turn on to energize this side of the power rail here. So let's start by measuring right here. We're putting a voltmeter in voltage mode, and we're going to measure right here. We should have 20 volts, and we do have 20 volts. And on the output of this, we should have 20 volts also, and we do. So we have the 20 volts coming through here, so that's all working good. Now we're gonna have to take this off so we can look underneath here. There's gonna be the MOSFETs that produce that main power rail of 12.6 volts right below this. So let me take that off real quick. All right, now that we have that off, you can see that this voltage comes over here, and it's going to come to this side of this MOSFET. So we have 20 volts on this side, and on this side we should have the 12.6 for the main power rail, and we don't. We have 0. And this is the gate pin that is controlled by the power management controller, and it will take that 20 volts and pulse this pin to produce the 12.6 on this output here. And I don't see anything here, so we're either having an issue where the power management chip is not working, and so it's not controlling that pin, or the power management chip is detecting that there's some sort of issue on the motherboard, like a shorted component or a shorted power rail. So it's preventing that MOSFET from turning on, and it's kind of protecting the motherboard from any further damage. Okay, so let's unplug the battery and the USB-C charger so we can do a CMOS reset real quick. We're just gonna need to discharge all the power from the system and just make sure it's not like a frozen BIOS type of situation, which could cause a similar issue. So let's do that real quick. So I have all that unplugged, and now I'm gonna hold down the power button for 10 seconds. All right, and then let's plug the charger back in, and let's see if it tries to start drawing some current. If it draws some current, then that means it was just a CMOS reset issue. But if it doesn't draw any current right now, then we know that it's going to be something further down the line. It's probably a shorted component on a different power rail, and then the power management chip is protecting the motherboard from having any further issues. So now that we've confirmed that it's not a frozen BIOS type of situation, let's start measuring all the power rails and see if we can find a shorted power rail. So back under the microscope we go. So what I usually like to do is I start to just check all these, the big coils. Those are going to be the power rails. So again, this one's the main power rail here. We're going to put it in continuity mode this time, where if you touch the probes together, they beep. And let's measure the main power rail, and we're not getting a beep here. The main power rail here is not shorted out. Let's check this current sensor resistor right here. We got 1.4 ohms. That's a very, very, very low resistance. So this is going to be after the main power rail is produced here. This one connects to all the other power supplies, all the other power rails like the 5 volt and the 3 volt and 1.8 and 1.2 and things like that. So we could have an issue on that rail itself or one of these other ones. So let's measure these real quick. So we have, this is the 3 volt and the 5 volt. So let's measure those real quick. This one's okay. This one's okay. So the 3 volt and the 5 volt, I don't see an issue on those. The chipset power supply, I think, is in a different location on this board. This would, on the older boards, the chipset used to be right here, but they actually moved, these are the Thunderbolt controllers, but they moved the chipset underneath the heatsink to have it right on the CPU. But let's measure this power rail right here. This one's fine. Okay, so I'm gonna have to pull the board out. We may end up having to go to voltage injection, where we induce a low voltage but a higher current to figure out what component is shorted out. And we're going to be looking at it under the thermal camera to find that. So, but first, let me just pull this motherboard out and we'll continue testing. All right, we have something interesting going on here. While I'm taking this apart, I'm trying to get the LCD connectors off, and this is all melted over here. So normally, this would not be this shape here. So, you see how this is like I mean, this is strange. You see the shape of this? This whole area is malformed, and this whole screw top is melted. So this should just pop off. See if I can get this to lift up. Okay, there it goes. That's what's supposed to happen. So that means that this was getting really, really hot right here. I can see this coil is a different color a little bit. All right, let's get this motherboard out and then we can take a look. All right, the motherboard is out. And I'll go ahead and pull this heatsink off too while we're at it. All right, before I pull this heatsink, let's look at this, because I could see that something's been going on here. I think this is just heatsink compound. Does that mean that somebody has opened this before? Probably. But let's take this off, and we can see if somebody has added heatsink compound to it. Yeah, this is still wet. This is very new, so somebody has taken the heatsink off and added some heatsink compound to it. Wow, look at the difference in color. So these have been kept cool, and these are almost look like they're melted here. And these are the MOSFETs underneath here. That power, these power stages. I think this goes to the GPU. These are all the power stages for the CPU. 1, 2, 3, 4, 5, 6, 7. And then these 3 are for this GPU right here, which I think is like the 10, probably a 3050 or a 4050 Ti, something like that. But this definitely looks like it has some color here. So I wouldn't be surprised if one of these MOSFETs are burned up. This one does look like it's actually burned up. Is that solder coming out the side right there? Let's zoom in a little bit. Ooh, look at that big solder ball. Nice. Whoa, okay, look at all that. Oh, okay. Has this been replaced or is, oh my gosh, look at all this solder coming out of here. Wait a minute. What? What? Has this board been worked on? Look at all this solder. Has this board been worked on? Okay. I'm gonna have to talk to the customer about this. Either this has been spilling out solder out the underneath them. Oh my gosh. Or someone has replaced these. I mean, these are, I mean, oh my gosh, there's a lot of heat going on here. And then this connector was melted. I'm starting to think that somebody worked on this. But how would they have been able to change those out with it heatsink on? I was thinking that maybe they didn't take the motherboard out. Maybe they took the heatsink off and then they replaced those with it still inside the motherboard. I mean, with it still installed into the laptop. Let's see. Trying to see if this looks melted or something, because that's a lot of heat that would be generating, but everything looks fine here. I don't know. I guarantee that one of those is shorted. There's a lot of solder sticking out the side of those. Oh my gosh. This is pretty interesting. All right, shall we measure? Let's do it. We have continuity mode. I'm just gonna take this off, get this out of my way, this sticker. Okay, let's measure from ground first. So this side of this capacitor is 0.02. This side of this capacitor is 1.3. Okay, and then I'm assuming that this is measuring 1.3. Yep. All right, so this is how it works. If this MOSFET's tied to the 12.6 main power rail, it will send the voltage straight through here, straight through the GPU, okay? And so that's why when we measure the main power rail, quote unquote main power rail, so 12.6 volts, when we measure there, we're getting 1.3 ohms. But also when we measure on the actual coils for the GPU, we're getting the same. That means that that's shorted straight across here. So one of these is shorted. I would say both of them are shorted because this is absolutely nuts, the amount of solder that's sticking out of this. I mean, I can't even comprehend. I mean, this totally looks like someone changed it out. But I guess there's a chance that there was a bunch of solder under there and they got really hot and then they started spewing out solder like that. This one looks absolutely, oh, there's a little solder ball in this one too. But see, look at all this. This is like flux. This is like flux, like somebody has been messing with this board right here. I don't know. I don't know. I'm just going to replace all 3 of those because I don't have any idea why it looks like that. I'm going to look at the other side of the board real quick. I just want to see if there's any signs. I'm just trying to be a little bit of a detective to figure out if somebody has worked on this or not. So we're looking at the other side of the board. This is the opposite side of where it looks like it was all cooked. And I don't see anything obvious. I can see that it almost looks a little bit discolored here. This is melted right here like this. That's melted a little bit. But I don't see anything else. Ooh, there's a hair. This is not my hair. Look, it's long and curly gray. Not mine. we're going to have to do some forensics on that to figure out if somebody's been in here. Okay, back to the other side. So before we continue, I'm going to make a quick phone call. I'm going to call this customer and see if I can get the full story on this, because I'm interested to know exactly what went on before we continue, so I'll be right back. Okay, I just got off the phone with the customer. He said that he had opened it up after it happened to figure out if he could see what happened to it or whatever, and he noticed that there was a little bit of melting on this little cover right here. So this goes across here, and you can see that it was melted there. So he noticed that, but that's all he noticed, and then he just put new heatsink compound on there and put it back together. So he said it was a new laptop. So this is a 2023, so it's only a year and a half old ish. I guess we can look at the date. Sometimes it shows me the date on here. But anyway, so it's not that old. I don't know why it would be overheating like this. These machines are very reliable. Most of these XPSs will last about 5 to 7 years, maybe 8 years. I mean, there's a lot of them that are still in service. So this one being only a year old or a year and a half old, it's kind of strange. So here's what my take is on it. So these two MOSFETs are definitely burned. I don't know which one, maybe one was starting to fail and making the other one stress out, because a lot of the times these are working in pairs, or they're working together. And so if one starts to fail or stops working, then it will make the other one work overtime. But this area definitely got really hot, and so it started liquefying the solder, and so there's probably a solder joint inside of there that's bonding a couple power rails together on here. But we are going to replace those, and I mean, what I'm hoping for is that the GPU is safe. Because there's a power management chip on the other side here that controls these first couple MOSFETs that produces the main power rail, and because that has turned off the first MOSFET here to prevent power from going throughout the system, then I think it's probably protecting the GPU properly, and so we should be able to just replace these and everything will be back up and running again. So that's kind of the hope, and so let's start by removing these two MOSFETs, see if the short goes away, and then we'll get them replaced, and then we'll boot it up and test, and we'll run GPU stress tests and stuff like that. All right, so since the LCD connector is right here, we're going to have to protect this. We also have the VRAM for the GPU right here, so we're going to protect that too. We're going to try to blow the heat away from both of these things. It's going to take a little bit of heat to get these off, but especially if it's burnt, I don't know. We'll see. Hopefully it's not too hard to get these off, but we're going to protect whatever we can. So we'll put a little bit of Kapton over this LCD connector. This is a high temperature tape. And I'll do it also over this VRAM. We're still going to blow away from these two things here. Okay, so we'll face it like that. All right, let's get our air set up. Okay, we're going to do 450 degrees at 60% air. I'm going to put some flux in here. We got to get these. We got to liquefy this solder. Let's see if we can get these off pretty fast. We don't want to spend too much time in here. Okay, we got the first one off. Let's get the second one off now. All right, the second one is off. I'm interested. I want to take a closer look underneath the back side of these and see if I see anything interesting. And I don't see a ton of solder. This is strange. I mean, look at this pin right here. There's a lot of extra solder. Here's the other chip. That's this one right here. Yeah, I don't see anything obvious what the cause is. I'll wipe this down and then we'll check for the short. So that's ground. and the short is gone. This side's ground. And this is the GPU, 1.4 ohms. But if we measure here, it's gone. So the board should actually turn on without those on there, but we're gonna, which actually we could test that real quick. Let's do that. We'll just see if it starts pulling current like normal. It should turn on automatically. And here we go. We're gonna plug it in. And we're pulling current. And shut off. Let's see if it turns back on. There we go. Yep, CPU started booting up and shut off. All right, so the short is gone, and now the board's going to try to turn on a little bit. But let's replace those and see if this GPU survives. Place your bets. I would give it a 50-50. On this one, I mean, the protection circuits on these newer boards are pretty good. So it's pretty good at isolating and making sure that the main voltage doesn't go through the GPU if there's a short over there, or even CPU. So I think that we probably have a 50-50 chance of that surviving. But we don't know how long this has been going on. If it's a heat-related issue, I have no idea why it happened so early in the life of this laptop, because it's pretty strange. I don't see a lot of these failing. So I think this is just kind of a fluke that this happened. So let's get these replaced and we'll continue testing. All right, so here's the deal. I don't have any of these MOSFETs in stock. I was trying to find some on a donor board. I do have one donor board that has the same chips, but I'd rather just order some new ones. So I did find them on DigiKey. It's going to be it's an AT00 is the marking on the chip itself, but that's actually an AOZ 5016QI. So DigiKey has them in stock. So I'm going to get some of these ordered right now, and we'll continue whenever the chips come in. All right, we got the new MOSFETs delivered from DigiKey. It actually took a little while. I like to order from Mouser most of the time because Mouser will deliver next day to my location, but DigiKey usually takes about almost a week. So it's kind of a pain in the butt. But here we go. What we're hoping for is that the GPU did survive, because when you do have a shorted MOSFET like that, it does send like all the voltage straight through the GPU and it can damage it. But the power management chip should protect it. And so we're hoping that that has happened. But let's go ahead and get these chips installed and then we can continue testing, all right? All right, let's get under the microscope. We still have this stuff protected, which is great. You can see that these have a discoloration compared to this one, so that we definitely had a lot more heat over in this area. And I'm hoping that once we get these on, then everything will be resolved. I'll add some extra thermal pads here to keep this cool. So we could take a look at the heatsink and make sure that the pads that were on the heatsink were making proper contact, and if they're not, then we're gonna go ahead and add more, because it's probably a heat-related issue that damaged these in the first place, because this machine isn't very old. But let's get these installed so we can continue testing. All right, we'll add a little bit of flux, and then we're going to add some more, some fresh solder to these pads. All right, we got that all ready. All right, so we have the pads prepped. Let's go ahead and get these new chips installed. All right, pin 1's there. Here's pin 1 on the chip. All right, let's start heating it up. This will take a little bit of time. Okay, we got the first one installed. Okay, that looks good. right, the first one's installed. Let's get the next one installed. All right, chip number 2 is installed. I just got to clean it up and let it sit down in there good. And there we go, it's seating itself. All right, now that we've got these chips installed, let's clean up the area a little bit and then we'll reassemble and test. Let's check for a short. Make sure the short is gone. And we're good. So there's no short on the motherboard. We have the new MOSFETs installed. All right, let's reassemble and test, and we'll make sure that this GPU survived. I think it's a 50-50 chance, but we'll see how it goes. All right, we'll have to clean off this thermal paste and put fresh thermal paste on. We'll put the new heatsink on. I'm going to make sure that these have a pad that keeps them cool and that it's making contact with all these different chips so we don't have any overheating issues in the future. When we boot up, we're going to see if we can get into a Windows operating system because a lot of times when the GPU is bad, you'll have it reboot on the boot up. So if we can get the Windows, then that's a good sign. And then we'll run some stress tests. We'll run firm-arc GPU stress tests. We'll run Prime 95, which is a stress test for the CPU and memory. And so we'll kind of push this to the max and see if it can handle all those operations. And then if everything passes, then we'll be able to get this back to our customer. All right, before I put this heatsink on, let me show you the design on how these chips are supposed to stay cool. So if I set this down like this, you can see that there's this middle metal area that goes right here. And this is what's actually pressing down on those DR MOSFETs. It doesn't have a screw support, and it kind of bends, it's kind of flimsy. And so to me, it looks like it might have gotten bent up just a little bit. See how it moves like that? So I'm going to make sure that it presses down a lot, make sure it has plenty of pressure on it, because I'm thinking that it wasn't applying full pressure there. And if we look at the indentation under the microscope, you could see that it was making pressure on something else over here. I don't think it was actually pushing on there. It looks like it was pushing on the capacitors and not the actual MOSFETs. So I'm going to make sure that these get lined up perfectly on these MOSFETs to keep them cool. Okay, so now when I was putting on there, you could see the indentations of the MOSFETs. So I do have it properly applying pressure to those MOSFETs now. Okay, heatsink is installed. Let's get it back in the system so we can run our tests. All right, the motherboard is installed. Let's go ahead and plug it in and see if we can get it to post. And if we can get it to post, then we're part of the way there. All right, plugged in the charger. Okay, we got the Dell screen for a moment. Okay, so we're pulling 3.72 amps, 3.7 amps. We got the Dell screen, so we're a part of the way there. So we know that the system now has survived at least. It didn't catastrophically damage anything else. The CPU seems to be working if this is coming up, but we still haven't gotten past this Dell screen yet. So it's always going to take a little bit longer on the first boot up because there's a CMOS reset that's happening, so it's going to have to go through a few cycles. Okay, now we're pulling almost 5 amps, 5.5 amps. Jump to 4. So it is moving around, so it means it is doing something. So we're on the right track. So let's just let this sit for a little bit longer and see what happens. All right, this is good. So we got the Secure by Dell BIOS screen, which is perfect. So now this machine shut off. It should come back on. There it is. And then we should get, I have his hard drive in here. So if we can get it to boot to Windows, then we know that the GPU survived. Okay, date and time has not been set. That's part of the BIOS reset, the CMOS reset process. So we're good. So we're going to hit continue. And we'll see if it can boot the Windows. If we can make it all the way to Windows, then most likely the GPU survived. And then we can run some stress tests on it. Windows booting up, Windows 11. And as long as it doesn't reboot, we're good. We made it to the Windows login. Okay, so now we're probably at a 95% chance that this GPU survived. We can't log it. This is the customer's operating system. So I'm going to put our own test operating system in this, and then that way we can boot and run our stress tests. So let me do that real quick. All right, we have our test operating system in here. Let's now boot to Windows, and we can run our tests. All right, it's looking good. Pulling 5.7 amps, 6 amps. We do have the battery in there, so it's going to be charging a little bit. So it's probably pulling 3 amps to charge the battery and 3 amps to run the laptop, something like that. All right, it's booting to Windows. So this is my test operating system. So it's going to boot up. It's going to have to find the devices. It's going to have to configure itself. So this is going to take a second. So I'll come back whenever that's all set up. All right, we got a blue screen, but this is an inaccessible boot device, which means that the way that the UEFI is set up is probably set to RAID or AHCI. I got to figure out which one it is, and we got to flip it. So my install was configured to boot in a different format than this is set up as. So we'll see. Okay, so this is set on RAID on, so I think our install is probably in NVMe mode. So let's go ahead and set it to that and reboot. So that blue screen isn't a bad blue screen. It's just telling me that it can't access the drive properly because the BIOS is set differently than what the install was set up for in the first place. So, all right, getting devices ready, so that's good. All right, we're in. I just need to check to make sure our devices are set up. So I'm going to go to Device Manager, make sure we have the driver set up for the NVIDIA card. It hasn't been detected yet. It still has some drivers to install, so we're going to let it run. But I guess there's a chance that the NVIDIA card isn't even showing up at all. So, because I don't see it in Device Manager right now, and I actually don't see it as an unknown device. So that's interesting. We could have a graphics card that's not even showing up. Okay, so I'm not showing it detected in the device manager, so let's reboot and go back to the BIOS and make sure that it shows the NVIDIA card there. All right, we see the battery, here's the processor, here's some memory. Devices, we have Iris video card, and then dedicated GPU is not there. So for some reason, the GPU is not even being detected. So I got to look into that. That's actually a pretty strange one. The easiest way to disable a dedicated GPU like that is to take off those MOSFETs, but we have the MOSFETs on there. So maybe that third one's bad too. Maybe we should get that third one replaced since we have more of them. So I'll have to shut down, we'll have to pull out the board again and do some tests. I want to see if we're having voltage actually come through those MOSFETs. There may be another issue in that area, or it could be whatever was controlling those MOSFETs actually failed now. And so, or the GPU's just dead. I mean, and that's definitely a possibility. But I mean, at this point, at least the laptop works and the customer could just take this laptop back the way it is. They just don't want to have the dedicated graphics. But we're going to do our best to see if we can get the NVIDIA card to show up and start working again. So let's shut it down. Let's pull the board back out and take another look. Whoa. Oh, it's hot. Okay, so, I mean, this is so hot. Oh my gosh. Okay, I'm going to boot in the diagnostics. Before I pull this board out, I want to boot in the diagnostics. I want to see how hot this is actually getting, because that, I mean, it seems excessively hot. I just want to be able to see what the temperatures are, because, I mean, I couldn't even touch that heatsink. It was so hot. Fans are running full blast. So the CPU hit 97. The CPU is currently at 97 degrees C. Why is that? Why would the CPU be at 97 degrees C? That is ridiculously hot. Video's at 30. I mean, I've never... 98, it's getting hotter even. The fans are running at full. The heatsink is burning hot, which means that, I mean, the thermal compound's there, so it's getting it, it's putting it onto the heatsinks. Is the heatsink bad? The way you can test to see if a heatsink's bad or not is if it's not getting hot here at the end, if it's only hot in the middle. But I mean, I can't even touch this. These fans are on full blast. I mean, it's blowing air, it's dissipating the heat, but this is just, whoa, ow. Okay, so we have a different issue. Okay, and these coils are not hot. This is where we have that issue. This is the MOSFETs we changed out, and these coils aren't hot. So I'm suspecting that the NVIDIA GPU is not even on. But why is the CPU so hot? CPU's at 95C. I mean, it's not even doing anything. Now the CPU's down to 85. The CPU went back up again to 92. I'm going to blow some of this freeze spray at the end of the heatsink right here where the fan is, and I want to see if the I want to see if the CPU temperature drops really rapidly. If it does, then we know the heatsink's fine also. That's another test. So I'm freezing the end of it. All right, so keep an eye here. We get the CPU's at, okay, it just dropped down to 86 from 91. So we're going to spray it again. So it's at 84. Let's spray it again. And I'm only spraying where the fan blows because I want to make sure that the heat's making it all the way to the end of that heatsink. We got the CPU down to 71. So we know the heatsink's fine. And we know that the thermals for the heatsink is actually making it to the CPU, but why is the CPU being maxed out or overvolted? I mean, I don't understand. Let's see, we got a BIOS of 115. I think we're on 120 or 130 something. So let's update the BIOS and see if that fixes this issue real quick. It's not too many versions out actually because it's only 1.18 and I think this one's at 1.13. So it's about 5 versions out, but I don't know what's causing the issue with it overheating like this. We're just hoping it can get through this BIOS flash because it's running so hot. We'll just let that run and we'll come right back. All right, we flashed the BIOS. We're back in Windows now, and the CPU, the temperatures seem to be a lot lower here. I do see some cores that are spiking to 100, but for the most part, it's staying in the 60s, which is great. But one other thing I just noticed is that now the GPU is showing up. We have a 4060 GPU that just showed up inside the device manager. So that's interesting that now that I flashed the BIOS to the newest version, it fixed all that, it fixed that issue there. So let's continue. We're going to go ahead and we're going to do some tests here. I mean, now that the CPU is staying at a relatively normal temperature, let's go ahead and open our GPU stress test tool, which is going to be FirmMark. All right, it is detecting the 4060, and I'm going to go ahead and start that stress test real quick. We just want to see if the system just reboots and stops working. It's hanging. Does that mean it's not going to work? I was just thinking about it. It's not. It's suspiciously stopping every time I click on something. Okay, there it goes. In progress. It's loading. It may just take a second for it to start up for the first time under this install. All right, still having a little bit of issue. So here's what I'm going to do now. Now that we have it kind of partly working, I want to make sure that all the chipset drivers and power management drivers and all that stuff is installed on this operating system, because this is my test operating system. And just because the device manager kind of shows everything installed, it doesn't mean that everything's good. I mean, here's a fingerprint reader that's having an issue, but because there's going to be chipset drivers that are for this device, and Windows will install like a generic one, and so you can never just trust it like this. So I'm going to go to Dell, we'll go through and install all the new chipset drivers, and then we'll continue testing. I just tried touching these coils that were on those MOSFETs that we replaced, that goes to the GPU, and they are so hot, it's almost like they're about to, I'm getting first-degree burns, I feel like, on my fingers. So we still majorly have an issue. Ooh, and those MOSFETs are hot. So I'm suspecting that we're having a GPU issue, and that's what's causing all this overheating issues on this. Ooh. I can't really trust that we successfully repaired this motherboard, because I think that the actual silicon must be messed up on this GPU, and that's causing it to short out these MOSFETs. and cause a lot of heat on this. So this is probably going to be a candidate where we're going to have to disable the GPU altogether, pull those MOSFETs off, and then just run it without it, or just replace the motherboard. But I'm going to keep messing around here. My fingers are, I feel like I burned my fingers by touching that. All right, I'm installing the chipset drivers just to see if I can get this working on this machine. But the graphics card, the NVIDIA graphics card has disappeared again. It was so hot, it did burn my finger. So I think we do have an issue with that graphics card, and it's not going to be repairable. But I'm going to go ahead and update all the drivers, and we'll do another reboot and see if we can get this partially working, at least working without the graphics card set up, and see if we can get it working as a regular laptop without that NVIDIA graphics card installed. This is an i9, so it's going to run a little hotter than an i7, and you can see that there are cores that are hitting 100 here still. For the most part, they're in the 60s. I do see them spiking into 100 degrees C. Let me install the Intel Power Management package for this laptop and see if it helps that i9 run more efficiently and not overheat. Okay, so I got those installed. Let me restart the computer real quick. All right, we're booted back into Windows. Let's check some temperatures now that we have the chipset driver installed and the power management package installed. All right, so we are down in the 60s again. But what I want to look for is I want to see if we still have it spiking into the 100. So let's run the Prime 95 stress test. This will stress all 14 cores at the same time. And let's see what happens. So we got it immediately spiked to 100. And when it hits 100, it should thermal throttle, but we just want to see if it can handle this without having some sort of overheating situation. Okay, you can see all the cores are at full blast. And we're not having, it's not too bad. I mean, we are having it hit 100 here, but it's actually better than it was a few minutes ago. We're going to let it sit for a little bit longer here. Let me feel it. It's definitely hot, but I think it's managing. And let's check to see if that NVIDIA card is still missing. It is. So this is, I think what we're going to do on this one, we're just going to take those MOSFETs off. I'm going to offer to take the MOSFETs off and just use this as an Intel i9 with Iris graphics laptop only. If the customer does want to get their NVIDIA graphics card working, then they're going to have to replace this motherboard, because I think there's something wrong in the silicon, because those coils and those MOSFETs that are driving the GPU are getting excessively hot. They're almost melting themselves, and there's really no reason for that. If you recall, we saw the MOSFETs had like solder bubbling out the sides. That means they got so hot that it actually could melt the solder. So there just must be a flaw inside that NVIDIA chip, and it's just a fluke, and it's probably a manufacturing defect or something like that. So those are going to be the options I'm going to give the customer. Okay, I talked to the customer, and the customer decided to just disable the NVIDIA GPU here, because there has to be an issue within the silicon that's causing this burning up of the 3 power stages. The way that I disable this GPU is I just remove the 3 MOSFETs that are on that power stage and the 3 coils, like this. You take all these off here, and then no longer is the NVIDIA GPU powered. And so now it boots to Windows and runs all the stress tests, and then now the CPU actually stays within range a lot better. So I think what was happening is with that NVIDIA GPU just kept turning on and then spiking heat straight into this heatsink, because this is a shared heatsink. So the NVIDIA GPU was actually causing the CPU to look like it was overheating, which it wasn't. So now everything is running perfectly. I'm going to get this back to our customer. He's super happy to get this thing working again. And if you have any questions or comments, I would love to hear them. And thanks for watching.
I saved another laptop!